Hello, everyone. Okay, welcome to day 2 of the QGIS training. Please, I hope you've all downloaded your data. Okay, good. So today we'll be looking at some simple terrain analysis, rainfall, and temperature analysis. So first, we are going to open our QGIS. For those who were not here last week, I'll just go over some short processes on loading your data. So when you want to load your data, you can simply drag and drop onto the map layer, or you go to the Open Data Source Manager. If it's a vector data, you select vector. If it's a raster data, you select raster. Today, we will work with DEM that I sent to you and some also shapefiles. So first, let's load in all our data sets. I hope by now you all know how to do that. So let's load in our data sets for today. So we are loading the DEM for now, and also the boundary shapefile. Add the climate shapefile too. Okay, let me give a brief explanation on what these raster data sets are. So we have our digital elevation model, which is simply a raster representation of the Earth's topography. So we can use this for analysis such as slope, aspect, or hill shade. So we'll go through these three analyses shortly, then maybe prepare a map for that. There's DEM, you've seen that. Oh, sorry, the shapefile, the country, yeah, the boundary and the climate. Yes, so make sure you are loading in the shapefile, the file that ends with the SHP. Are you okay now? Okay, so let's move on. We are going to start with developing slope for our DEM. So for that, you can go to your Processing Toolbox. This little icon here. This Processing Toolbox. So when that is open, you can, if you are not finding the tool you are looking for, you can simply just type in raster terrain analysis. But then it's just right here. So we'll move to this raster terrain analysis. The tool that I have expanded here. You can see aspect, hill shade, slope, relief, and other terrain analysis there. But we are going to do just 3 today. So we are going to start with the slope. Are we seeing it? Yeah. Or? Yeah, still downloading the data. Are you lost? Oh, yeah, not. Please, I'm giving everyone some 2 minutes. Kindly be fast with downloading the data.
Start from here. We have to learn. Just shut up because you are.
Okay, let me start from loading data sets. Please, I'm going to start again. We are going to start with loading our raster and vector data set. If you want to load any vector data set into QGIS, you are going to go to Open Data Source Manager. This one right here. You click on that. If it's a vector data you want to load, you make sure that you selected the vector here. When you are done, you come to these 3 dots, you select it, and you locate your shapefiles. Sometimes if the files are too many and you're not finding the one that ends with SHP, you can just come here where you see the type, the drop down, then you select the shapefile. Are you okay? You go to Data Source Manager, select Vector. The 3 dots, there's type here, use this drop down to filter out the shapefile. So when you find what you're looking for, you can simply highlight everything. We are using these 2 shapefiles for today's work. So you highlight and then you open, then you add to the map layer. You just click on this add here. Good. So we are going to do same for our raster data. We go to raster, the 3 dots. We load in our TWN DEM. You click on it, select open, then you add that one to your map layer. When you're done, you can just close this one. Okay, we're good? Sure. So as I was saying, we are going to start with our slope analysis. So slope simply means the steepness of a terrain. You can use this for maybe landslide studies, flood risk, or construction. If you want to see how steep a slope is, you can use this function here for that analysis. So this, we have Processing Toolbox here. Can you see this tiny icon? Like, I don't know how to describe it. Yeah, that one. So you click on it, you are supposed to see this whole dialog, which contains all the toolboxes for QGIS. So you can simply search for the slope. Sorry. And how come? Let me see that. No, not that. The QGIS looks old. Which QGIS is this? Downloading version?
No, my manual.
There should be some here. It's been a while since I used this version, sorry. Okay. That's very strange. Okay, let's have the name. Give me a second. Yeah, Augustine will help you. Look for attributes toolbar and activate it. As I select here, when you can't find the toolbar, you should be able to see attribute toolbar. Yeah, that's why it's your toolbar. Interesting. Please find it for me. Or better still, if you have good internet connection, download the latest version of the QGIS. Okay, so let's move on. So we search for our slope, we double click on it, and we have this dialog here showing us what we have to input for our analysis to run. So for here, QGIS can automatically detect the raster data set for you. So it has been highlighted. This is a very simple step. When it's done, you can select where you want to save it. So these three dots, you go to save to file. Let's create another folder for it. And you can name your file slope. When you're done, then click on the run. When you click on the slope, when you open this dialog, input your elevation layer, you leave everything as default, you select where you want to save it. You use these three dots to select where you want to save it. So you save it to file, you locate where you want to save it, then you click on the run. I guess the QGIS is very old, so the new one. Okay, are we okay? Are you okay? Oh. Are you good? You're not good? Not at all. So we are starting over with the slope again. Kindly pay attention. You go to your processing toolbox, type in slope. You see it here. You double click on that. This dialog will open. You have to specify what you are working with at the elevation layer. This one. So we are going to select our TWN DEM. You can leave everything else as default. Then you select where or which file you want to save your final output. So you click on these three dots, you go to save to file. Then you can name it as slope. Here, you type the name here. And then you select the save. When you're done saving it, then you can proceed to click on the run. So you have your slope here. I'm putting the raster boundary. Giving you some few minutes, then we move on to the next terrain analysis. Don't worry, we'll come back to symbolize this layer so that you see how the end result is. Okay, so we are moving on to the next terrain analysis, which is aspect. Just as you did for the slope, you go to your processing toolbox, and in the search, you can type aspect. When you type the aspect, you double click to open the aspect that is under this raster terrain analysis. So for that, it's also the same process. You're going to select your DEM. If you are working with DTM too, you can select that. But we are going to work with our DEM that we are working with, the TWN DEM, not the slope you just processed. So it's also a similar process. You leave everything else as default, then you save where you want it to be saved. When you're done, you click on save, and also for that, you can click on the run. So for the aspects, for the aspect, it shows you the direction in which the slope is facing. So let's say if there's a steepness, whether it's going 360 degrees, 180 degrees, that's what this analysis tells us. So let's symbolize these features before we move on to the next, that's the hill shade. So to add a bit of color so that you see the differences well between the numbers you have here, you are going to right click on the layer aspect. And then you go to properties. We want to clearly see the differences in our aspect layer. So we right click on it under layers here, we right click on aspects, go to properties, and then search for this symbology. When we get here, we are going to change it to, this one is showing just one band of the layer, but we want to see everything clearly. So we are going to select the single band pseudo color that is under the render type. We are going to select this. Let me go back. We are going to select this single band pseudo color. So we can see that we have interpolation, color ramp, and so on. Here we can select discrete. Then we can change the color. You can change the color to any color of your choice. Let me go over again. You go to your layer aspect, select properties. You change this to the single band pseudo color. Then you change it to this discrete or discrete, yes. Then you can come here, select the color you want to assign to your layer. I'm choosing this spectral. You can apply to see the changes. Also, we can go with equal interval. Equal interval enables us to see the numbers clearly and simply. Under the mode here, we have equal interval. When you are done assigning your colors and changing some of the parameters, you can just go to OK. Assuming you want to see the particular degree, or let's say the direction in which a particular space or slope is moving to, you can kindly locate this identify feature icon here. Please search for your identify features icon. When you click on it and click on any area, you should see the value of that particular area. Usually the dialog will be at your right hand side of the QGIS. Maybe you want to see the aspect of this area. When you click on it, it tells you 332. You go to another portion, you click on that, it gives you the value. Let's go over again. If you want to see or know any information about a feature, you click on this identify feature icon. This one. Then you come to the layer, you click on any location that you are looking for. You'd see the value of the layer there, here. Likewise, if your identify feature icon is still active and you move on to, let's say, another layer, and you click on any portion, you'd also see the change in the value. Okay, so just as we did for the slope, we are also going to add a bit of color. Sorry, just as we did for the aspect, we are going to add a bit of color to the slope. So you right click, go to properties, under the render type. This render type, make sure you are selecting your single band pseudo color. We change this to discrete and also change the color. Let me go with this one. For the mode, we are going to go with equal interval to understand it clearly. When you're done, you can click on the apply. We are seeing this color because QGIS is telling us that probably the area, majority of the area has a similar slope. So the color should not bother you. Okay. Are we okay up to this point? Or we are still lost? Sorry? Still lost? Yes, as I said, basically probably majority of the area has the same slope, similar slope values. You get it? So confused. Okay. If you don't understand anything, you can call me so that I go back to it. Thank you, thank you. Next, we are moving on to hillshade. Are you okay? Next, we are moving on to hillshade. So the same process, we go to our processing toolbar, then search for hillshade under this raster terrain analysis. So we are going to double click on our hillshade. For this, we are going to import our DEM, our TWN DEM. Most of the processes are similar. So once you're able to do one or two, the rest shouldn't be so difficult. So we click here, select our DEM, this DEM. When we are done, you come below here, you see save to temporary files. But we want to locate a path in our desktop or anywhere to save this layer. So we come here to these three dots, click on it, and we save that to layer. So we are going to name it hillshade. When you are done, you can move on to the run. So hillshade is simply a shadow effect based on terrain and the sunlight angle. Usually they use this to help in maybe visualization of maps. If you are doing some hydrological analysis or anything, yes, you can move on with this one. So once you are done, you apply the same process of symbolizing, just like the aspect and the slope. So for the raster terrain analysis, analysis such as aspect, slope, and hillshade usually follow the same process. Again, if you want any particular information, you click on the identify feature and then you select the location you are looking for. So you see the change in the values at this identify results part. Also, you can decide to change the color of your DM. You add color and some classification to it. When you want to move or deactivate the identify feature, you can come to this pan map icon here. You click on it to be able to move your layer. The pan map, this one. You activate that, you click on it. You'll be able to select your layer to move around. Or which one are you talking about? To change the color. Oh, yeah. So you right click on your DEM, it's the same process as the aspect, yes. Go to properties, you change it to the same. This one? Ah, yes, just select and select the equal interval. The color, you right click on the TWDM, you go to properties. You select the single band pseudo color. This one. And then you select the discrete. You can use this drop down to change the color. Any color of your choice. Be able to see, make sure you are choosing colors that allow you to see the differences clearly. And for it to be able to be very easy for us to identify the ranges, we are going with the equal intervals. When you are done, that's when you click on the apply and OK. Okay. Are you good? Okay. Are you okay? No, don't mind. Okay.
I do look for color. What's the moment of the
Yes. I'll go to the party. Oh, wait, let me just change it to another one. Okay, it does change. So, nothing wrong. I'm good to go. I can change the color of this one too. Are we good to go? Oh, yeah, no good. Please help, mister. Yeah. But he is getting it, so you can ask him for help. That one depends on, you can change. Yeah, it's okay. It's okay. That's your preference. Go back to how you did this one. No, this one.
color change?
No, this the yeah. Go to properties. I didn't use this. I used this one. This one. Yeah. Oh. I should think so. So click on OK to see if that's okay. Apply OK. I didn't use my phone. I'm coming. You can choose any color you want. That's what I use. They're terrible. Okay, so we are going to create a map out of this. Please, when you're done with your maps, you can share in the group. So to create a map in QGIS, we are going to, first let's save our progress. So to create a map in QGIS, we are first going to go to project here. You click on this project. You move down to new print layout. Click on project, you search for this new print layout. Then you just single click on it. So you go to project here on this toolbar, select new print layout. You should see this prompt telling you to name your map. So we can give it terrain analysis. Go to project, locate your new print layout. You should see this prompt telling you to name your map. We are going to type in terrain analysis. When you are done, you can click on OK. We are creating a map for what we have just done. Once again, we go to project, select new print layout. You give your map a name. You should see this new window appearing on your desktop. Okay, at this point, our map layout is in landscape. When you click on it, you'd see the properties of the paper on the right-hand side of your print layout. Over here, there is landscape, there is portrait. These way you are selecting the paper size and type for your maps. Make sure it goes with whatever layout or however your layer looks like. For example, our Taiwan DEM here is kind of horizontal. So it makes sense to choose a portrait orientation for this kind of map. You can just zoom in and zoom out. To change the orientation of your paper, you click on the empty space. You should see this on the right-hand side of your QGIS or the right side of your QGIS. And then you select the portrait. Now, to load our map onto our print layout, we are going to click on this. We are going to click on this add map here. The paper with the green plus, the plain paper with the green plus. So we're going to click on this add map. select any area, specifically the corner of the paper. You hold it, then you drag it across the print layout. Let me do that again. You click, you hold, you select this one, add map first. You click, you hold, then you drag across the layout. Okay, so from here, we are going to add some elements to our map. So you can also change the scale if you want a full extent of your DEM or layer. Let me make this probably 11. Okay, so you should get something like this. From here, we can add more layers to our map. You can see this text box here. You can use that if you want to add a title. So say we select, drag across any area. Automatically, the main properties will appear. You can just delete this and maybe we call it DEL. You can change the appearance of how your text looks like. And you scroll down, you see appearance, you are going to just click on the font. And then maybe we change the size to 28. So let's go back and select our print layout and then add a bit of border to it. You see the item properties appear. You are going to just scroll down. And go back. Then add a frame to your map so that you can get some clear borders. Also, every map needs a clear direction, so we are going to add our north arrow. On the same line, you see this blue icon with the green plus. You can click on that, and in the same way, you hold, you drag, then your north arrow is there for you. How you place your elements on your layout is very important. So kindly take notes of that. Now we can also add other things such as a scale bar, which is right on top of the north arrow. We click on it, drag across where we want it to be. Then we get our units here. Right now, I'm just showing you how to add the elements to your map layout. When we are done, you can design the map the way you want it. It should be clear. It should be able to communicate what you want it to communicate, and then you export. So lastly, another important part of making a map is adding a legend, which is also right on top of the skill bar. We are going to click on that and drag across where we want our legend to be. This is for the aspect. If you don't want a particular feature to show in your legend, you can come here and probably highlight only show features inside current map. Sorry, inside current atlas feature. Or you deactivate the auto update. Let's say we want everything except the aspect. We can just click on that and remove it. That's remove selected items. Or you can just go back to your map where we are doing our analysis and deselect the items that are there. Also, select only show items inside linked maps. These ones. Highlight them there. Okay, lastly, if you want a grid on your map, you are going to select your print layout, this map that you have here. You scroll down. You scroll down, you go to grid. Then add a grid. When you add the grid with a plus sign, you see the grid 1 here. And when you add another grid, you see grid 2. But we just need only one grid. So we're going to add that, and then we modify it. Here, there are various ways to determine the X and Y values or X and Y lines of your grid. Sometimes you can do this manually. Let's make it 5. 5 is too small. So yes, you can do this manually. If you are doing it manually, you really have to know the extent of your layer to be able to correctly get the grid on your print layout. Yes, so you can take time to learn these parts of the map print layout. So if the grid one, when you want to add a grid, you make sure you selected the map. Then you are going to scroll down, you see grids. You click on the plus sign. The grid 1 or 2 or 3 will appear here. So we are selecting our grid 1, then we modify the grid. When you come here, you can determine the interval. Let me change it so it makes it smaller. So as I said, you have to really know the extent of your map layer before you can be able to determine the grids. When you are done, if maybe the lines are distracting a bit, under these line style, there's the arrow here under the line style. Choose the drop down, then you can reduce the opacity of the line. You can use 1, 1 for the interval for your grid, the X and Y. Okay, let's move on. And then another important part, to add coordinates to your grid lines, you are going to scroll down and then you click on the draw coordinates. You can decide which kind of coordinates you want, whether decimal, whether you want it with a degree, minute, second, it's up to you. Just click on this, then you select the type of coordinates you want. I'm going to go with this. For the left and right part of it, you see it's horizontal. If you want to make it vertical, the left here, you change this horizontal to either vertical ascending or vertical descending. You do the same for the right. You change the horizontal to any vertical that you want. For the other features, you can later explore them for making your maps. Okay. Now, if you want to export this map, maybe you are done, you are good with what you are seeing, and you want to export it, can either export it as an image. When you come to the top here, you can either export it as an image or as a PDF. So the first one is exporting as an image. Then the second one as a CVG is also another file type. Then, exporting as a PDF. So you can either export as image or PDF. Let's export as PDF. When you do that, the name of the print layout automatically shows here. You can choose to go with it and just save your image. Here, you don't really have to do anything. You can just go ahead and click on save. Your final map will be saved. So when you go back, you can do the same process for your slope aspect and hill shape. You can also save your print layout and minimize or close it. So that's it for terrain analysis. We'll move to rainfall and temperature analysis. To avoid confusion, if you are done, you can clear the ones here. Are we okay with the terrain analysis? Okay, so we are moving to rainfall analysis. In your, as part of the data set, there's this precipitation data. So kindly unzip that and add it to your map layer. It's a net, I think, CDF file. So the same way you add your raster layer, you can add that to your map layer. You can simply drag and drop, or you can take the long process. But up to this point, we all know the long process, so we can just go to our file, locate our rainfall data. Please make sure this is what you have in the folder that I sent you. There's 2004 days and 2004 monthly. That's what we'll be working with. Okay. So if you are sure that's the data you have, we'll go to Open Data Source Manager. Make sure we've highlighted raster. Go to these three dots. It's the same process, so we already know that. We open our precipitation, and then we select the days. There's days and there's monthly. We are starting with the days. And then we add to our map extent. Please, let's take some 5 minutes break. And within that break, if you have any questions, you can let me know. Sorry. Please, did you unzip the file? Yeah, so please, the same way we've been adding the data set. So I'll go to the data source. Open, yes. We've highlighted the raster, that's fine. So we can go and search for the data. Oh, I don't know where you saved it, so if you could. Day 2. No, there should be inside. Oh, okay, okay. Yes, the precipitation. Yes. So we are open here. We are starting with the days, with the first one. Yes. And then you can add it. You can zoom out to see the full extent of it.
Can I open it?
Yeah, should be able to. No, no, this is not your file. So open another one. Did you save this as your file? Okay, no, then open another project. Oh, Chinese. Oh, you've already. So we are done with this part. We are moving to another. Yeah, so close this one. You want to know the processes? They're making the map.
Okay, yeah.
Oh, okay. Don't worry, we'll use the. No, yeah. When you open the QGIS, you'll see some of the recent projects from the software. You can open the precipitation data. No, this one. Then raster, yeah. Then we search for, I don't need a precipitation. This is your precipitation. You can also put over there. We are starting with the days, yeah. Then you add it. We add it, add. Yeah, so we can close it. Please, are you okay? Well, I want to make a good map. Okay. 5 minutes is up. Two. Please, I'm sending a file to the WeChat group. We will use that. Where is the WeChat group? Uh-huh. Okay, I've sent a file to the group. So first, we want to calculate the sum and average of rainfall of a particular maybe month. So this data set is 2024. When you right click here, then you go to the properties. You can view the number of bands. For checks, for these types of data sets, if you see the name as whatever you have there, then the year dot days, you'd usually have 365 days, which tells us that it's the 365 days of that year. The band name according to the day. So you see band one, it means day one, day two, yes, that's. If you see 366 days, probably that year was a leap year. So we have 366 bands. So we are going to calculate the sum and average of January for that year. That means that we'll be working with band one. Since January has 31 days, we work with band one to band 31. To do that, to calculate the sum, we are going to go to Raster app here. Then open our raster calculator. You should see this on your machine. We are going to open our raster calculator. Once again, we are calculating the sum of our rainfall for the month January. So we are working with band 1 to band 31. Ideally, the process is to select, then you click on add, go to day 2, select, click on add, and so on. But it's a long process. That's why I sent the file to the group. So you're going to open that and simply copy what I sent to you. I've added all the 31 days. So you're simply going to copy, then you can paste in your raster calculator. If you are the one doing the analysis, depending on the number of days, you do your own addition. This one? Yeah. So I went to the properties here just to view the number of days I have. So you see band 1, as I said, the band represents the number of days. If it's 365, it's 365 days. 366, 366 days. And we are working with January. January has 31 days. So we are working with band 1 to band 31. We want to calculate the sum of rainfall for January in that year. Sorry? Yeah. Yeah. So we are calculating the sum of rainfall for January. We go to raster, select the raster calculator. If you are doing it manually yourself, you are supposed to double click, add, you double click on the days, then you do the addition. But 31 days is a lot, so I already did that here in the file I sent. So you can just go and copy that and paste it in the raster calculator expression. QGIS should tell you that your expression is valid before you move on. When you are done on top here, you should save your output layer. Right here, we use these 3 dots. Choose a folder where we want to save it, and let's name it Sum Rainfall for January. So we are looking at the total amount of rainfall for January. If your expression is valid, specify where you want to save your file, and then you move on to naming it in QGIS. Make sure the output format is GeoTIFF. QGIS has frozen. Okay, after the process, our software has displayed the sum of our January inputs. You can zoom into any area, use the identify to see the rainfall values. So here is Taiwan. You can see the various rainfall values for the month of January in this year. Symbolizing raster data follows the same process. So you can also go to properties. You change this to the single band pseudo color. Because it's rainfall, let's go with something like blues. Then we move on to equal interval. You can change the number of classes. Usually 4 to 5 is preferable. And then we click on the apply and OK. So we can see the areas with the very low rainfall values and areas with the high rainfall value. Are we good? Or I should go over another one? You're okay. Okay, so we are calculating the sum of rainfall values for the month of January. Our raster data set, rainfall raster data set, comes as a daily data set. So you will have band 1 to maybe as where. You couldn't do what? I'm confused. You couldn't get this one. Where should I start from? I guess. Let me see. Give me a second. Oh, it's even slow. You know what? Um, can you use the mouse too? Yes. Are you okay? Yeah, she's okay. Oh, okay, okay. You know what? We'll move on because of time, so I'll come to you. Okay, so we have calculated our sum of rainfall for January. So you can do that for February, March, April if you go back. Now let's also calculate for average rainfall. This is the sum. We are calculating for the average rainfall for the same month. So for that, we go to our raster calculator, the same procedure, but this time make sure the additions are in brackets. And then we are going to divide this by 31 days. We are looking for the average rainfall. So it will be the sum over the number of days. So the sum in brackets, then we are dividing by the number of days, which is 31. So if it's February, you definitely divide that one by either 28 or 29. If it's June, by 30 days. So when you are done with that, you specify where you want to save it. And we give it the name average January. Okay, when you're done, you can move on to the okay. So you can see the average rainfall values for January. We can also assign a different symbology to that one. And by now, you know the process of adding colors to your layers. So for average, maybe I'll go with greens. Then we change this to equal interval. You can change the number of classes or you can leave it as default. Once again, The number of classes that is preferred is usually 4 to 5, depending on your analysis. Then we click on OK. So these are the average rainfall values for January. If you want to know a specific area, use the identify tool to know the values for a specific area that you are looking for. Are you lost? What's lost?
Why did this change my cases?
You're using this one.
Yes. But when I
Mhm.
let me show.
I'm coming to this.
So this
No. So we are going to select it from here. Yeah.
yeah. This
Yeah, this is for the average. You can use any color. Yeah. Yeah.
oh,
Yeah, so you can do the same for the sum.
did for the sun.
Oh, okay. Yeah. Then you are good to go.
Yes.
You can change the color. Just use colors that are visible. Maybe you can make it green because that one was blue. Okay. Mm. Yeah, that's the whole. I'll get to that part. Because that's even the next one. Yeah. Oh. Huh? How many layers of it?
Yeah.
January, so 31 days. So 31.
So put them in.
Yeah, put them in brackets.
Start at the end.
How many minutes? 30.
But how many?
How many notes now? I'm sorry, yeah, NDV anyway, but not my read.
Divide it.
Are you okay? No, I will follow the new version. Okay, so let's move on to the next point. If you want to extract this to your region of interest, we are using our Taiwan boundary. Previously, we loaded our Taiwan country boundary, this one. If you deleted it, please bring it back. So load in your Taiwan country boundary. You can move this one all the way to the top. You can also change the symbology for this by right-clicking, go to Properties. Symbology for vector data is very different from raster data. So right-click, go to Properties, select Symbology. Then we have single symbols. There are other categories too, but the one that's perfect for this type of data set is single symbols. In case you are working with maybe a regional data set and you want to see the differences, you can use something like categorized. If you are working with numerical vector data set, you can use the graduated. So we leave it as single symbols. We use this arrow here to reduce the opacity of the layer. So as purple, you can use this tiny black arrow to make it blank. When you are done, you click on apply and OK. I did that because I wanted to be able to see the boundary whilst also seeing the raster data in there. Okay, so we are going to extract this region of interest. To do that, we go to raster, then we go to extraction. The menu toolbar, we go to raster, then extraction. We are going to select the clip raster by mask layer. Go to raster, select extraction, and then we move on to the clip raster by mask layer. Sorry? Yes, we are extracting for this region of interest. So make sure you have your EWN country boundary. Go to raster, extraction, then the clip raster by mask layer. Here, our input will be, you can start with average or sum. Let's start with sum, then you do the average yourself. We input our sum, January, and then the country boundary is already selected. If it's not, use this arrow to locate your shapefile. Then we go to the assign a specific node data value. We are going to choose a value of this. Let me zoom in. We are doing this because if usually you don't assign a data value for raster extraction, the software is going to give you a rectangular kind of shape. But then we want the shape of the boundary or our region of interest. We don't want a square or rectangle or anything. So we have to set this large data value. Sometimes we use this or 0 so that it doesn't interfere with our major data sets that we are extracting. So we use this data value, then we can click on the run. Oh, sorry. Before we do that, let's export this to GeoTIFF. Right click, export, then save as. Some of the processes are more fast because we did that last week. So if you can let it help you. So export your layers to anywhere you want to save it. We're choosing our projection. And then, okay. After this, you change the color back to what you used to have. So a single band pseudo color. My green is already there. Let me make a blue, sorry. Selecting blue. And then, okay. So let's extract again our region of interest. Oh, sorry. Yeah, I'm using my sum January, my country boundary. Then I set my no data value. So this is our rainfall sum of rainfall values for January for our Taiwan. So we can do the same extraction for the average. Are you okay? Oh, yeah, lost. So we extracted for sum, extract for the average. We can apply this same process to a temperature data set. If you want to calculate the sum and the average temperature of a particular month, you can do same for that. Okay, please, any question? All right, let's move on. Sorry, you are stuck? Okay, let's go over extracting your region of interest again. So if you want to extract your region of interest, if you are working with the data set and you realize that there are question marks here, that means they are probably temporary layers or they missed some CRS. So you have to export it to a file where you can easily find it or where you want to put it, and also assign a coordinate reference system to it. So I already exported my January. I'm going to export my average rainfall values. So I right click on the average rainfall, go to export and select save as. You make sure the format in which you're exporting is a GeoTIFF format because it's a raster data set. There are other raster data sets, but we are working with GeoTIFF today. So make sure you have GeoTIFF selected. Then you use this to locate where you want to save your file. You can name it average January. And then we move to save. We have to specify a coordinate reference system. We are using the default, which is the WGS 84. So we select the project CRS. When you are done, they will ask, or the software will ask, do you want to add? Yes. You leave that as ticked. Then you move on to OK. From here, it will appear as the same black and white. So you can change the colors. So now we have our exported average rainfall. To extract your area of interest, today our area of interest is the country boundary of Taiwan. To extract the values for that boundary, we are going to raster. We move on to extractions. And then we select the clip raster by mask layer. Make sure you select your average January as your input layer and your boundary as your mask layer. Here we are specifying these values for our no data value output. You can either use this or 0, but I prefer this one. When you are done here, then you click on the run. You get just your region of interest showing on the map layer. anytime you see something like this, it shows that your feature or layer is temporary. So you have to export that. And we know the process. Okay, so that's it for extracting your region of interest. Are we okay? Sorry? I'm coming, I can't hear you. 2 seconds. Yes, export it. No, the first one. Yes. Please, sir, have you given up? Yeah, no, you select where you want to save it. Then you name it, then from there, I think you know the rest. Yeah. Yeah, I lost. You've now loaded the data set. The boundary data. No, not this one. Go and load the boundary. There's another one, shapefile called boundary data set. Not the one. Yeah. No, go to vector. Yeah. Then the 3 dots. Then go back. QGIS. This one is the shapefiles. Then this. No. There's one that has shapefile. Can you go to this? Oh yeah, that's it. That's it. Yeah, okay. Then add it. So use that one for the extraction. You get it? Yeah. Now, yeah. So your max layer will be the boundary. Then you set where you want to save it. No. This one, assign no specific data value. Yes. Yeah. So that doesn't interfere with the actual data set. So you can use that value of 0. Mhm. Yeah. So run should appear here. This one. Then you can export it. Are you okay? Don't count. Are you okay? Or you are lost? Are you okay? Okay, so you're playing along. You good? Is she good? Thank you. Okay, so we have one last thing to do for rainfall, and then we can close for today. So you can deactivate all the other layers and load in your TWN climate vector data. So kindly load in the shapefile, your point shapefile. We are going to perform an interpolation on this. So spatial interpolation simply lets you define values for areas that do not have any data based on known data values like these points. So for example, Let's say you have a rainfall data from a few weather stations. The data that you have here, interpolation will help you to identify the other values around this data set and areas that also do not have data. We are going to use a process called the IDW interpolation. So to do that, you also search for it in your processing toolbar. Any toolbar that you need, you are going to find it here. So please type in the IDW interpolation. Just IDW, you are going to see it there. So this process or feature assumes that points that, let's say, are closer to each other are more similar to points that are far away. In simple terms, in your neighborhood, if let's say you want to find out the weather for your neighborhood, you trust a weather station that is, let's say, 1 kilometer away rather than a weather station that is like 20 kilometers away. So this is what this process simply does. It uses the available data to also detect or assign values to other areas that do not have data. So we are going to double click on the IDW interpolation. The software has already automatically so the software has already automatically selected our climate data. In that shapefile, there is mean temperature and there is precipitation. Let's start with the mean temperature, then you can do the precipitation on your own. So we select the climate, use the arrow to select mean temperature. And then we use this little green here, this green, to add it to this vector layer part. Make sure when you select, you add it to this layer. When you scroll down, you can also specify the extent to which the interpolation should work on. So you click on this drop down, then you tell the software to calculate from layer. So we are going to select our boundary, which is the country boundary. So depending on where you got your rainfall data and your region of interest, you select your station's data, then you select that boundary. After that, under this interpolated, you say save to temporary file. If you don't want to save it, you can go straight away, or we specify where we want to save it. So click on the dots, then move to save to file. Almost all the processes, you have to specify where you want to save your final output. So let's name our final output interpolation, or just IDW. And then we save. So let's make sure everything we have here is correct. No, there's a different data. Do you have this TWN climate? It's part of the data sets that we sent this morning. You've loaded that. Yes, so you go to your processing toolbar, type this IDW, you double click to open. Your vector layer should be that TWN climate. And in that file, there's mean temperature and there's precipitation. So we start with the temperature, then you can use the same process for the precipitation. When you select that, you use this plus sign to add it to this layer. And then under extent, here, you can specify where the interpolation should, the boundary in which the calculations should take place. So we are selecting the boundary shapefile. After that, we are saving to where we want it to be, as usual. So we can just name it IDW, then save. After you are done, you check if everything is okay, then you can move on to run. So the IDW is here. Using the same process, extract by mask, you go to raster, extraction, then the clip raster by mask layer. This time we are using our IDW. Then our mask layer, as usual, is our country boundary. We set our no data value. It's the same process as the other one we did. Then we click on run. Oh, sorry, I'm not done. Wait. Let me do it again. Then I said my phone, maybe. You want to change the 10 to 12? Yes, please, under target extent, you specify your boundary. I need you mine. The same thing. Oh, sorry. Yeah. So you should have this. You use the same process to, as usual, change the symbology of your layers. So this is also another way of estimating rainfall or temperature values. This is for temperature. So you can use the same process for the precipitation. Temperature, I would like to select red. Then we applied and okay. If we want to see the values for a specific area, we highlight our identify features. When you click, you would see the values over here. Hmm? Okay, so that is all for today. If you have any question, you can text me, and I'll also send to like how I did last week. I'll send the steps so that you can practice on your own. Yeah, thank you. Yes, I sent, so I'll send it again. Or I'll send you the steps for you to work on it. Yeah. So please, that's it for today. Tomorrow we'll continue with something else. Yes, tomorrow.